Alright, now we get to see an application of completing the square, and in this particular case we're going to use it to write the equation of a circle in standard form. Now the standard form for the equation of a circle is the x part squared plus the y part squared equals the radius squared. And typically we associate a negative h and a negative k with x and y respectively. And so let me first point out that here you have a perfect square, and here you also have a perfect square. The idea is completing the square gives you perfect square trinomials, and so that's what these two guys are. And over here you simply have a constant, so we're going to sort of pull away all of our constants that we need to the right side, and that's going to contribute to the radius squared. So let's begin. So here's a pretty simple example. This is the equation of a circle, but it's not in this nice little form where it's easy to identify the center and the radius. So that's where our goal is going to be, to make it look like this up here. And so the first thing I want to do is get all of my x terms together and all of my y terms together, and do nothing with the other side. And now what we want to do is we want to take the x part of this and make it look like this, which means we need to change this binomial to a trinomial. And I do that by adding something to it, and I have to figure out what to add, okay? So I'm trying to make this a perfect square by adding something to it. Similarly, I need to do that with my y's, right? I need to make that a perfect square as well. So I need to add something to this binomial. Don't forget to bring down your plus in between those. I need to add something to this binomial to make it a perfect square trinomial as well. And then if I add something on the left side, this is an equation, don't forget, so I need to keep it balanced. And so if I add something on the left side, I have to add the same things on the right side. So whatever I add in these two places on the left, I have to add on the right to keep the equation balanced. So now I need to figure out, just on this guy, how to make it a perfect square. Well, if it's x squared minus 2x, when I go to factor it and make it a perfect square, I need something times itself to give me x squared, so that's x and x. Then each of these guys need to come together to give me negative 2x, so that'd be negative 1x and negative 1x, so I need a minus 1 in each of those places. Okay, so we're just completing the square here. Let me erase these negative 1x's, and now we've factored what this must be. So the constant up here comes from negative 1 times negative 1, which is positive 1. So I have to add a 1 to this first one, and I need to add a 1 over here to keep it balanced. We do something similar here. To get y squared plus 4y, I'd have to have y and y. And then to get a 4y, I need a 2y and a 2y, so each of these has to be a plus 2. So the constant on this side is 2 times 2, which is 4. So I need a 4 there to make it a perfect square. Now just bring down my plus, don't forget that, and on the right side I have 5. So we're very close to this now. I've got perfect squares, I just need to write them that way. So x minus 1 times x minus 1 is x minus 1 squared, plus y plus 2 times y plus 2 is y plus 2 squared, and 5 is 5. Now this is the standard form for this equation of a circle. If you want to do more, you could identify the center of this circle as 1, negative 2, and the radius as the square root of 5. Okay, let's try a harder example. So in this example, I'm going to group my x terms together. I'll group my y terms together, and there's only one of those this time. And I'm going to move my constant over because I need all my constants to sort of be absorbed on the right hand side. So I subtract 8 from both sides. Now I can tell that I'm going to have to complete the square here on the x's because it's a binomial and I need to make it a perfect square trinomial. However, on my y's, it's not even a binomial. That's a hint that you don't want to complete the square, right? You can't complete the square unless you've got two terms. So we're going to leave that guy alone for now. And also, to make our life easier when we go to complete the square on the x's, I'd like to have the 1 here. That would make completing the square much easier. Luckily for us, this is an equation, so I can do things to both sides of this equation and keep it balanced. So to get rid of this 2, I'm going to divide both sides by 2. And on the left side, that gives me x squared minus 6x plus y squared, and on the right side, that gives me negative 4. Now I can complete the square here. So I need to add something to that to make it a perfect square trinomial. I'll copy down my plus y squared equals negative 4, and since I'm introducing something extra on the left side, I have to balance it on the right side. Now if I go to factor this, you should see that you're going to get x minus 3 times x minus 3 to get the negative 6 in the middle, and the constant that I'd have to add up here would be the negative 3 times the negative 3, which is 9. Keep it balanced. Copy down the rest of it now. Negative 4 plus 9 is 5 again, and we end up with x minus 3 squared plus y squared equals 5. So this is the standard form for this circle. Now, you may be confused by this. It doesn't look quite like this. So if you prefer, you could write it as x minus 3 squared plus y is y minus 0. So you could write it as y minus 0 squared equals 5. And in either case, you could see that the center is 3, 0, and that your radius is the square root of 5.